Imagine falling from a height of 5 meters right now. You'd probably break some bones. But if you knew how to land safely like a parkour expert, you might just walk away unharmed. But what if you fell from 100 meters? You'd almost certainly die. But if there was a huge airbag waiting below, you might actually survive. Now, what if you fell from an altitude of 10 kilometers? You might think, I'll just open my parachute. But what if it turned out to be just a regular backpack? At this point, survival seems completely impossible, right? Surprisingly, you'd be wrong. In 1972, someone actually survived falling from an altitude of 10 kilometers. Her name was Vesna Vulović, and she even made it into the Guinness Book of World Records. In fact, no matter how high a person falls, there is always a tiny chance of survival. But how could this even be possible? And why was this woman falling from 10 kilometers up in the first place? Well, it certainly wasn't some crazy science experiment. In this video, we're going to explore the amazing scientific secrets behind surviving a 10-kilometer fall. The flight that day was perfectly smooth, at least for the first 45 minutes after takeoff, until the plane exploded. Jet Airways Flight 367 departed from Stockholm, scheduled to travel to Belgrade via Copenhagen and Zagreb. At its first stop in Copenhagen, a new crew boarded the plane. Among them was Vesna Vulović. Unfortunately, she wasn't even supposed to be there. Due to a clerical mistake by the airline, she replaced someone with a similar name. At that time, no one could have imagined that this small mistake would completely change her life. 45 minutes after takeoff, at an altitude of around 10 kilometers, there was a sudden explosion in the forward cargo compartment. The plane shattered into pieces and plummeted toward the ground from an incredible height. Surviving such a fall seemed impossible, but unbelievably, there was one survivor, Vesna herself. Although she suffered multiple fractures and fell into a coma, she miraculously recovered, astounding the world. Later, Vesna amazed everyone again by becoming a member of parliament. So, how exactly did she survive? What incredible scientific principles lie behind this seemingly impossible event? Let's explore these remarkable secrets together. We tend to think that the higher you fall, the more dangerous it becomes. But in reality, beyond a certain height, the exact altitude no longer matters. Would you believe that falling from 10 kilometers could actually be just as survivable as falling from 1 kilometer, or even safer in some situations? Surprisingly, this can be true. The reason falling from a greater height is typically dangerous is because of gravity. Gravity accelerates falling objects, making them move faster and faster, much like a snowball rolling down a hill. But there's one common misunderstanding here. Objects don't keep accelerating indefinitely. After all, snowballs don't grow forever either, right? As an object falls, it collides with countless invisible air molecules. This air acts like a cushion, resisting the object's movement. And the faster the object falls, the stronger this cushion becomes. We call this air resistance. It's like a tough opponent who fights harder as you push harder. As the object's falling speed increases, so does the air resistance, until eventually air resistance equals the force of gravity. At this point, it's like an intense tug-of-war match that's perfectly balanced, with neither side giving an inch. From then on, the object's speed stops increasing. This is called the terminal velocity. For humans, terminal velocity is roughly about 200 kilometers per hour. If you position your body vertically to minimize air resistance, you can fall even faster. If you spread your limbs out widely, you'll fall slower. Heavier people generally reach a higher terminal velocity because gravity acts more strongly on them. So how far do humans have to fall to reach terminal velocity? Surprisingly, only around 580 meters. In other words, beyond about 580 meters, whether you fall from 1 kilometer or 10 kilometers, the danger is essentially the same. It might sound unbelievable, but it's true. But is this enough to explain Vesna's astonishing survival? Because even if you hit the ground at 200 kilometers per hour, you'd almost certainly die, right? The second secret behind her survival comes from ski jumping. Imagine the breathtaking ski jump events of the Winter Olympics. Athletes leap from towering ramps, soar through the air at tremendous speeds, and land safely on a steep slope. We nervously watch, certain their legs would break upon impact. But incredibly, they glide smoothly down the slope, completely unharmed. When you think about it, isn't that strange? Do these athletes have legs made of steel? The secret lies in the slope itself. When landing on an inclined slope, we can separate the falling speed into two components, one perpendicular to the slope and another parallel to it. The dangerous impact force mainly comes from the perpendicular component, while the parallel component simply helps the jumper slide down. The steeper the slope, the smaller the perpendicular component of the speed becomes. If an object falling vertically hits a slope inclined at 60 degrees, it's as if the impact speed is cut in half. Vesna reportedly fell onto a snowy, steep slope, but even that still doesn't seem enough to guarantee survival. After all, even half the speed, about 100 kilometers per hour, still seems deadly. To fully unravel the mystery behind surviving a 10-kilometer fall, we need one more crucial element, and that's probably the deep layer of snow. An object in motion possesses something called momentum. Momentum depends on both mass and velocity. The heavier and faster an object is, the greater its momentum becomes. When an object hits the ground, its momentum is converted into an impulse. The impact force spread over a certain duration of time. If the impact force is distributed over a longer period, it becomes safer. If it's delivered in a very short burst, it's dangerous. Think about pouring exactly 1 liter of water into different cups. A narrow cup will cause the water level to rise high, while a wide cup will keep the level low. If the water level exceeds the height of the cup, it overflows. Receiving impact force is similar. The width of the cup is the duration of the impact, while the water height represents the strength of the impact force. The total area formed by multiplying force and time represents the total impulse. Consider dropping an egg on the ground. If it hits a hard surface, the impact time is extremely short, resulting in a large impact force. The eggshell easily exceeds its breaking point, shattering immediately. However, if the egg lands on a soft cushion, the impact time is extended, reducing the force. This way, the egg stays intact. Similarly, the thick layer of snow on the steep slope increased the duration of Vesna's impact, drastically reducing the force exerted on her body. Additionally, Vesna, who was extremely unlucky to be on that flight, happened to fall while still strapped to a piece of the plane's tail. This debris further increased air resistance and helped disperse the impact. Of course, we sincerely hope no one ever has to experience such a terrifying event. But if you ever find yourself in an unimaginable worst-case scenario, or even just a situation where you feel completely hopeless, remember this story. Even in a 10-kilometer free fall, miracles are possible. Keep holding on, and you might just find a way out.